My name is Alon Goldin. I'm responsible for the business in Europe at Velostrata. And I think we can probably start. So yeah, that's the high-level outline. It will take us about an hour and 5 minutes. Okay? So few words about Velostrata. So the division of the company was really to enable hybrid cloud for the enterprise, for the production workloads with a click of a mouse in a simple way that today currently is not yet available in the market. The company has been founded almost 2 years ago by two veteran entrepreneurs who during their life founded companies in wider network optimization, storage optimization, desktop and server streaming technologies. Maybe some of you heard a product called Cisco WAS, or equivalent of Nuernberg. So this was one of the acquisitions, one of the early technologies that one of the founders here established. OneNova was the other company that had been acquired recently, actually back in 2012 by VMware, storage optimization and desktop or OS streaming technology. Another founder comes from StorSimple and then acquired by Microsoft. And really the idea here is this huge market around cloud that is still locked for the enterprise because of some of the barriers, and we'll talk about these barriers. One question to you: do you participate or manage some projects that are related to cloud with your customers today? Anyone? Okay. Okay, good. So public cloud, private cloud?
Private.
Basically private cloud.
Yeah, up to now, but integration for AWS is planned for next year.
Okay,
Yeah.
okay.
And also we have connection from the internet to our, it's separated. We have internal private cloud and external private cloud.
Okay, okay. Okay, so you will be very, very impressed, I think, to hear about the innovation that now Velostrata brings to the market. The R&D of the company is in Israel, the headquarters in California. And the product, the idea of the product, we'll talk about it, is to be able to stream production workload in minutes with a click of a mouse into the public cloud while leaving the storage on premise. And we're talking about minutes, and you will see it in the live demo, regardless of the size of the storage, because the disk or the storage, the attached storage, stays on premise. Optimize the connection between the public cloud and the storage to ensure adequate or fast performance of the applications, and achieving all that without requiring the customers to move their storage into the cloud, lock them in certain cloud vendor. So you will see that. You will see that. Okay. And essentially, the problem that most of the IT organizations deal today is how to supply compute for their business based on the requirement of the business. And the majority of the companies today, they follow the first option, which is over provision, right? So which means you provision more infrastructure that you need for the peak periods in your customers, which mean, yes, you have, this orange line, you have enough infrastructure, but that infrastructure is often idle for the use case for the times that there is no peak and load. The other alternative is obviously provision it based on the average load, which means that when I have peaks, I don't have enough compute. So this is not the best way to manage your data center. And then there is essentially the big promise of hybrid cloud. Hey, why waste the infrastructure? Why build your infrastructure based on your maximum capacity on a peak load? Base your data center based on the average load and rent the spike. Essentially, take the spikes from the public cloud when you need it. This way, you obviously have optimized infrastructure in-house, and you have the agility to go into the public cloud for additional compute as needed. So this is the great dream. The reality is not many customers so far adopting this vision. So how about hybrid cloud today? Do you see in Germany, in your region, particular traction into this approach already? That the customers are essentially willing to have these capabilities. But the problem is that there are barriers. So there are certain barriers today in terms of how to adopt this vision. And the barriers is essentially there are kind of 5 key, I would say, barriers, and many you would agree to part of this kind of the superset of the barriers that we heard from our customers. So for example, obviously, some will have challenges, or they feel they don't like the risk of moving production workloads. Think about your ERP application, for example, or your CRM application that used to be on premise. Moving all that into the data center. It's not, obviously this is the fact that your data now is in public cloud, and also you're starting to lose the control of your data. The time and bandwidth it takes, this is another major barrier. So if you think about how long it would take to migrate 10 terabyte database, for example, from the data center into the cloud over 20 megabit link, it would take between 30 to 40 days. So the time to migrate this is very significant barrier. Complexity is another barrier. Okay, I know how to manage my infrastructure in the data center. I have all the practices that are built around how to manage, how to back up, replicate my storage. Now part of my infrastructure starts to sit in another way, in other clouds. It means that I need to learn different tools. I need to, there's a headache of how do I protect, how do I manage my backup, for example, of the storage in the cloud. How do I migrate my images? Because remember, if we have a vSphere, if it's a VMware-based images in our data center today, if you want to run them in Amazon, for example, in Azure, you cannot run them as is. It's a different hypervisor. You need to adapt the images. So you need to change or use different tools in order to change or update your images. And then, of course, there's also a question of cost. While public cloud is a great idea for the compute to pay for it just when you use it, but when you move the storage into the cloud, you need to pay for the storage 24/7 as long as it's there. And if you're talking about production level workloads that require adequate IOPS, we're talking about expensive storage. So these things become pretty much expensive when you think about moving sizable workloads into the cloud. And last, of course, even if I overcame through all of these challenges, I really feel locked in with my cloud vendor. What if I have a better proposal, for example, tomorrow from Azure? Now to start the whole process again, changing and updating and migrating from one cloud to another, it becomes something that is very complex. So these are kind of the key, I would say, barriers that we have heard from our customers and some of the partners today. Why today only 5 or maybe 6% of the enterprises leverage hybrid cloud concept today, which part of the infrastructure is in-house, part of infrastructure is in a public cloud. In your opinion, do you agree to all or some of the barriers that we are presenting? Yes? No? Okay, more yes than...
Additional barrier is the administrative overhead or the implementation, and it's a bit more, not big, so it's a huge effort to produce the automatism behind that systems and to develop that.
Absolutely. I mean, we talked about, we put it under the kind of complexity because it requires those orchestration, new ways, new tools, processes. Absolutely. So it is there. So the founding team and the engineering team thought about, okay, if these are the barriers, if I remove those barriers, I will be able to unlock the hybrid cloud vision as an opportunity for the customers. So these goals, essentially these 5, I would say, requirements were used as a requirement to build the product. And I'm going to present you what Velostrata has built. Essentially, this is the product that addresses or removes these challenges, and with that technology, the customer will be able to adopt this hybrid cloud promise as a reality. So the concept of Velostrata solution, and we start with high level and then we dive and also see a demo, is, okay, let's decouple. I want to decouple compute. I will run my compute in a public cloud while keeping the storage on-premise unchanged, providing without sacrificing the performance. This is essentially what Velostrata does. And some of you or all of you would say, you know, this is impossible. But yes, we found kind of a secret sauce that enables this detached, I would say, architecture that solves these challenges. So the solution starts essentially its life in a data center here. You know, it's a small virtual appliance that is installed into the hypervisor, and this is where all kind of the practices that customer developed through the years are there. You know, the storage management, the infrastructure management. These are the things that we don't want to manage. This is the thing that we don't want to change. So this is a small virtual appliance that is installed. And then there is a peer appliance that is installed automatically, provisioned into a cloud. It could be AWS, it could be Azure, and it would be other clouds as well next year. This virtual appliance essentially automatically provisioned. It's scaled up and down based on the needs. So, for example, if you need more infrastructure, or they will automatically grow in scale, and they will automatically be reduced or turned off from the cloud when there is idle activity. So we'll talk about this in a second. And then essentially you choose the virtual machine using the vCenter management console as before that you want to run in a cloud from some reasons. One reason could be I need more CPU, for example. I need more resources for my server or for my application. So all you do is you right-click on a virtual machine in a vCenter, and you say, okay, I want to run it in a cloud. So what will happen then is our solution will stream a certain amount of blocks into the cloud, the necessary blocks for perform the adaptations. So, for example, this is vSphere infrastructure, and this is Amazon, for example. So we adapt the image automatically in the background, and then we boot this machine in the cloud. So this process, and you will see, it takes between 5 to 7 minutes. And after 7 minutes, we have a server that runs in Amazon, for example. We preserve the same name as the original server, and essentially when the requests are starting, you know, when the machine boots and server loads, there are some requests to files, to logs, to operating systems. So them will be accessed through our virtual appliance in a data center that has an optimized channel open down to the storage in your data center. So we have a multi-tier cache here that essentially makes sure that obviously some blocks that we cache here could be used across different machines to optimize the performance. And now from that moment on, this optimized channel ensures that there is a good performance for your applications when they are accessing the storage on premise. Question? Any questions so far? Okay, you can feel free to stop me and ask the questions at any point in time.
Will you point out the details about the technology behind that?
Yeah,
I'm just wondering about the latency times and all that.
Yeah, so we will. Okay, so yes, ask those questions during the demo. But yes, essentially we have a customer that uses such solution on 180 millisecond latency between the front end, essentially the virtual machine in a cloud instance, and the storage. Okay, it really depends on, most of the application they run with a kind of defined working set. which is not unlimited and not too random. So we essentially are able to provide single-digit latency for read requests and less than 2 to 3 milliseconds for write requests. Why? Because we acknowledge writes locally here in the cloud, and we stream them back to the storage. So I will show you some of the example kind of reference from one of our customers who moved his CRM application that consists of several servers into the cloud, and you will see the performance metrics from there. Okay, but the idea is, remember, the secret sauce is two parts. One is being able to stream and boot the server in the cloud in minutes. And by the way, this is a reversible flow, so you can right-click on the virtual machine and say, okay, I want to run it on premise, and then it happens back, it rolls down, and you kind of bring back your server back to your infrastructure in the data center. And the other secret flow is, okay, now that I work in this detached mode, how do I kill this latency, essentially, between the instance in the cloud and the storage in the data center? Yes, please.
How do my clients in my on-premise connect to the applications running in the cloud?
By DNS. So today we preserve,
DNS.
it means we preserve the name of your server, Linux or Windows server. Okay? We do not preserve this version the IP, layer 3, layer 2 kind of.
Okay, but when I have private names?
That's fine, because essentially the solution takes care making sure that these instances here will have different IP than the original one, obviously. So the solution essentially makes sure that your DNS server is updated with the right IP addresses from the public cloud, from your VPC instance in Amazon, for example.
Yes, but do I need a VPN tunnel between my on-premise installation?
Yes,
okay.
yes. Okay, sorry, of course. By the way, everything is encrypted in rest, in flight and in rest. Okay, yes, there is a VPN channel. You can use any VPN solution your own from the cloud vendor, of course. So this is important. Okay, so, and the very important thing, the only management console that IT has is the vCenter. Or there is also APIs that enables you to define kind of automation if needed. But this remains the only management single pane of glass for the IT, just as before, to manage the servers that now could live in one cloud, on-premise or in another cloud. Okay, so just to summarize, if you remember the barriers that I was talking about, so authoritative data is kept on-premise. So your images, your disk stays on-premise. Okay. You will see that the technology that we have enables that image to boot and run in cloud in minutes, literally 5 to 7 minutes from the moment that you right-click here in the data center of the virtual machine. What will happen is the machine is turned off, prepared, boots, and starts running from the cloud. And as we mentioned, the single pane of glass, and there is no change in operation. You don't need to install anything into your virtual machines, nothing, no changes. No changes to the way you manage your storage, fiber channel, any storage you were using before. This is the same way you're using it after. And this is cloud agnostic in the sense that, AWS is already supported. Azure support comes in early 2016, and the VMware support comes later on our roadmap. But the idea is, you don't need to change anything into your images before you make a decision that you want to run it in one cloud or another. The solution makes the adaptation for you. Okay? So, there is kind of, I expect a little bit more questions about the technology, and I have kind of a special slide that shows, this is 15 years, I showed you the kind of the timeline of the team that were working across different companies. Lots of IT, lots of knowledge how to make sure that one optimized, the streaming is optimized, making sure that this is possible. So we will keep the slide just for some advanced questions you may have, and we will do a live demo. Okay? Right. So what I have here. Okay, excellent. I will sit for a moment. So, okay, we have what we have here is the use case I'm going to show you is we have a virtual machine. This is a CRM server, for example, that is overloaded, and you need more capacity. And your ESX host, you don't have more infrastructure available in-house. And using our solution, you with a click of a button, you can move that server into a cloud. It will run there. You can choose to run it, for example, on a bigger machine. That's the beauty of the cloud, unlimited compute capacity. You can choose larger instance, for example, to run it for the short period of time. And then it will be running, with the same load, and the server will be essentially offloaded because the application runs on a bigger machine. The ESX, the host, is going to be offloaded again as well because the machine is now running in a cloud. So you will see that in a moment. Okay? So Sugar CRM, this is our application, essentially our server that I will leverage a synthetic tool, kind of application load tool, in order to create load on this machine, and you'll see what's going on. So this is our server. So we are using WAPT. This is a benchmark tool, okay, to create a synthetic load on this server. Okay, so we will run a load test here on that machine. Now this, you can see here, we're talking about 2 CPUs, okay, with 8 GB RAM. This is my machine, my Sugar CRM machine. It has 3 disks, 40 GB, 1 TB. This is kind of the data disk, and another auxiliary disk of 10 GB. The importance here is I will show you that in the cloud, when that instance runs in the cloud, there is no storage actually consumed from that server in the cloud. Okay? So we started running the benchmark tool, and you can see the CPU on my guest machine is 100%. Okay? So far so good. Now, my CPU is 100%, so the application is a little bit slow. That's okay. But the problem is that not only when my guest is running on 100% CPU, it also impacts my my host. So if you first of all let's see, you can see essentially there's a spike of the CPU. You see the spike, the CPU on the machine goes to 100%, and let's go to the host. You see the CPU on the host spikes as well, 45%. Okay, so this is not healthy, right? Okay, well, I'm an IT manager. What do I do now? We have Velostrata. With a click of a mouse, and you will see that I will move this overloaded virtual machine into the cloud. Okay? Now, before I'm going to do it, I also want to create a state, just to show you that we preserve the state on the machine. So we'll create also a small file here. 100% CPU. What do I do? Okay. Well, you buy more infrastructure. But it takes you some long time, to get your infrastructure in-house. Why not leverage some, the infinite compute from the cloud? All right. So and by the way, remember this is my CRM server. So remember, they're the disks, right? So remember the 40 gigabyte, the 1 terabyte disk. Yes, on that machine. And what I'm also going to show you is I'm going to ping this. I'm going to ping this server so you can see the latency is 1 millisecond. So this is local. Okay. In a second, I'm going to move. So this is in Miami, essentially. That's why a little bit slow. I will move it into the Virginia. You know, it will run inside the public cloud in Virginia. You will see that the latency will be about 35 milliseconds. So what do I do? Remember, we mentioned that with Velostrata you can move your workload into the cloud in minutes. Yes.
Sorry for the disruption. Could you please do me a favor? Could you please set up a permanent looping? So while moving the machine to the private cloud, it should move. Okay, great. Thanks.
The IP will change. So if that's what you're.
Okay. Yeah.
Yeah, and we mentioned the IP is gonna be different. You see? Okay. All right. Any other requests before we start? Okay.
Where do I configure Velostrata inside? This is or after?
You configure it before, so this essentially there is
you show it afterwards.
Yeah. There is a one step. No, I will not show. There is a one step of installation of a Velostrata software appliance that is not. I'm not showing here, but this is this OVA.
Yes. Later on, if I add another cloud service or so.
You just set up the VPN connection. There is certain set of automation script that you need to define some some network parameters, security parameters, and that's it. So usually we have it's about few hours setup. Well, that's what we're talking about. All right. So back to our vCenter, Sugar CRM. Right click. You see there is a new thing. Is added here? Velostrata operations. Okay, so the only thing that IT needs to do is right-click on, run in cloud. Now, remember it was 8 gigabyte, 2 CPU. By the way, if I have more than one cloud, more than one extension, they will show up here. You can choose essentially where you want to throw this virtual machine into, but let's stick to we have only one extension here. So, what's the template essentially? What's the size of the machine we want to run this server on? And remember, we're going to pay. The customer is going to pay for the compute just during the time he will be running this instance in the cloud. So remember, it was a CPU intensive application. So let's pick up a stronger machine, like 8 CPU with 30 gigabyte RAM. The hell, why not? I have unlimited infrastructure now. I don't need to build it in my data center. So now there's two things. Policies. Write back means that the changes that I make while the server runs in cloud will propagate back to my storage. The other option is write isolation. It means that the changes will persist only in the cloud. When I return back my virtual machine, they will be lost. Where this is relevant, it's very relevant for the use case of Deftest scenarios when you want to test something without changing anything in your core environment. So essentially, think about it. This is kind of a read-only in terms of the changes to your disk on premise. So we'll choose the write back option. We choose the security groups, which is sort of a kind of a VPN, essentially. Kind of a firewall, making sure that it's going to be a secured access. The network. Finish. So that's it. Whoop. No. I'm not touching. All right. So what you can see here, can you? Yeah. You see, we essentially have tests. All right. Let's go back to our Sugar CRM. You see it has a red sign because the CPU is spiking. So what will happen is, and we have a portlet essentially imported and integrated here. in the vCenter. So you will see now all the statistics, all the information is going to be presented here. Single pane of glass. So what will happen now is the machine is going to be moved into the cloud. Let's talk a little bit about latency, bandwidth, etc. What we require essentially for that is a minimum of 20 megabit symmetric connection between your data center and a public cloud for up to 50 virtual machines. Now, where this 20 megabyte comes from, we want to make sure that the downtime essentially for application would be limited to 5 to 7 minutes. And our secret sauce knows essentially how to boot the server with just 2 or 3 gigabyte of data, no matter how big is the your actually data disk on premises. So transferring 3 gigabyte of data from data center into the cloud, it's about 5 minutes. Okay. The recommendation is for ongoing. So the recommendation is 20 megabit minimum, but 50 to 100 megabit for up to 50 machines. So if you want to do it for up to 50 machines, which is the kind of the basic sizing that we have, one the instance in the cloud and the instance in the data center supports up to 50 concurrent machine. We're talking about 20 to 100 megabit connection. By the way, if you have less, it means that the downtime would be longer. So in the meantime, let me show you what happens in the AWS instance. You don't know to see this, but what happens is that, where's my refresh? Okay. So this is essentially the footprint of our appliance in the cloud. In a second, you will see that once the needed information is transferred, an instance is going to be created here. So you will see here a Sugar CRM. In a second, the instance that we have chosen to run in Amazon. Now this is live demo. Okay, all right. So it's still preparing. Any questions so far, guys? Don't be so quiet. Or you are in shock from what you are seeing. Come on.
It's about the licensing and the pricing comes later, or?
Licensing and prices, yeah. I mean, we can just, yeah. Well, let me finish the explanation of what it can do, but yes, we can discuss this as well.
Preis kommt immer ganz zum Schluss.
But don't worry, it's all right. So seems like it's already running. So in the background, the instance has been created. You see the Sugar CRM here, the C4 large, the one that we have chosen. Okay. So a few more minutes. Now, the data center is in Miami. The public cloud instance is in Virginia. So here's our ping. We're still unreachable. Yes. Don't worry. We'll fix that. Now let's look into the instance actually that is being created. So from the storage perspective on that server, this is the footprint from, remember it was 1 terabyte disk and 40 gigabyte disk for the Sugar CRM on premise. This is the footprint of your server in a cloud. This is the standard 1 gigabyte disk that is attached. That's it. Let's come back to our vSphere. Now, usually to migrate, so if you think about it, what we would need to do if we wanted to migrate this machine into Amazon, for example, you need to change the image. You need to transfer a couple of terabytes of data into the Amazon. Imagine how long it would take. Now, so it's already running. It's still, all right, the status is it's still initializing. So in a second, it will say that, all right, it will be up and running. We will do remote desktop connection again to this server. And now what I will show you is a few things. One is it's going to be a different instance from the CPU and memory perspective. Remember, we chose 30 gigabyte RAM and 8 to 16 CPU processors. You will see the same disks are still there. Remember, the instance in the cloud accesses the storage through our optimized channel on premise. We will run the same benchmark that will now, because it's much stronger machine, will not bring it to 100% CPU. And the ESX host will be offloaded as well.
One question.
Yes, please.
What about automation? Is this only a manual task or?
No, you can create, so as I mentioned, it's natively integrated in vCenter, but we also have a kind of REST API that you can automate everything. All right, so essentially, seems like, so what happened is that the machine moved to, has been moved, okay. I will just, let's stop our ping. So IP has changed, remember, not surprisingly. Look the latency now. We're talking about 30 to 40 millisecond. Okay, so our server is actually now 40 milliseconds away. So it's hundreds of miles away from our storage. Let's come back and connect to the machine again. So now, essentially, it will run a little bit slower because we don't have the local disk. The disks are essentially remote, but the cache will warm up itself, and the performance would be nearly close to the same performance as before. So, by the way, remember, this is our demo file that I have created. Let's look at the so you can see we're talking about 16 processors, 30 gigabyte RAM. Let's run the benchmark tool again.
But one question
Yes,
is, if the server runs in the cloud, you said, okay, they changed the IP address.
Mm-hmm.
How did you connect it to the Active Directory, to the site and services? Well, in the site and services, in our company, we have different sites, and we have different IP ranges. And where did you connect this to the right site?
So the IP now comes from this is the public IP from the public cloud.
Yeah.
Okay.
But I need for that a connection that I have an internal connect to my site in the Active Directory.
You only choose a new site for the public cloud and say this is network 10, 20, whatever.
Mm-hmm.
That's it.
Yeah. You can define, you will know upfront the ranges of IP you will get from the VPC, from the virtual cloud and private cloud. So, to be honest with you, I don't have all the answers to all the questions. There's a limit of technicalities that I can address, but this work transparently. What it requires as part of the setup is you need to specify, and Amazon and Azure knows essentially. There is services that know how to update properly the corporate DNS. Okay, so the benchmark tool runs, and this time you will see that it's still preparing itself. So the CPU will go up, but it will not reach 100%. So let's wait for the benchmark to start essentially to start running. Okay, so the CPU started. You can see now Right. The CPU is not running under 100%. Let's come back to our vCenter, and what we will see here is by the way, okay, this is the portlet that explains exactly the properties of the machine. This machine is managed by Velostrata. What I want to show you now is the actual host CPU. Bear with me. I think I have a little connectivity problem.
Mr. Feinberg.
Come on, all right. So we can see the performance of our virtual machine is going down, right? And trying to connect to the host. For some reason.
Try to press the home button.
Yeah, it's coming. Hosts. So essentially, I'm connected over VPN to the office in Tel Aviv, and from there it connects to Miami. Our instance in Europe has not been activated yet. Yeah, but I think it's quite impressive. Remember, so essentially, let's look at our performance of our host that was really overloaded. So you see, this was when it was running with the original load on the smaller machine. Now the performance is offloaded, and just the same way, I moved the machine into the cloud just to complete the. Oh, hold on. Anything else you want to see here? This is our machine that runs now in the cloud. Remember the disks. The actual disks are here, the 1 terabyte and 40 gigabyte. Yes. Properties. Okay, so the storage is, storage is managed essentially, accessed from the cloud, from the instance in the cloud, back to the storage on premise. And the performance is optimized. What I will show you is before I move back the virtual machine on premise is also the average read and write latency, because this is important. I haven't heard yet the questions about, what about applications? What applications are good applications to be used to be migrated this way? I hope you are preparing these questions for the end. If not, if you will not ask, I will tell you. Don't worry. I would say in general, you can move any server, so the applications that are, for example, remember we have a cache in the cloud with a limited size. So if your application is kind of a big data or Hadoop type application that reads huge amount of data all the time, this is not the best fit. But most of the applications has kind of a working set, a warm set of of data they are using, and our cache is essentially, it has advanced algorithm to predict some of the behavior of the access to the storage. So essentially, we're talking about a high ratio of heat, which means heat is addressed from the cache in the cloud. That stores. Okay, this is what I want to show you. Obviously, the monitoring is also integrated. So you can see here, for example, the blue one is the read latency. You see that it spikes but then on the average it will essentially be on a sub 10 millisecond latency. So remember, when the machine was not in the cloud, there was no cache. The cache starts building itself, and there, more hit requests are addressed. So we're talking about the sub 10 millisecond performance. This is the performance of the write, of the changes that that benchmark tool does. So you can see here, essentially, this is the one utilization. There's our write performance. Read latency. I'm looking for the write latency. So, yeah, so you can see here, oh, this is IOPS. Here, the average write latency, we're talking about less than 3 milliseconds, which is, the writes are acknowledged in the cloud. All right, so let me complete the story, move the machine back on premise, and then proceed to essentially to explain you a little bit more, tell you what our customers are using this this solution for. So right click on the virtual machine, run on premise, that's it. By the way, you can reconfigure it if needed, obviously. Smaller machine and larger machine. Okay. There's a protection mechanism to make sure that the admin knows what he's doing. And and that's it. Now the machine moves back. Everything is integrated. So after about 7 minutes, it will be back on premise. Now I left the system running so we can come back to it in a second. I want to tell you, why is this? Okay, all right, that's fine. So the key use cases. First of all, any questions so far? No. Okay, key use cases, where we see the customers are leveraging this solution for. So far it's 5 main use cases. This one, I would say, these two are essentially the. So this is the hybrid. This is the true hybrid cloud. Data center extension and cloud bursting. So data center extension is essentially when I have planned or unplanned a peak in my load, I can extend, just as I've shown you here, my infrastructure, run it in the cloud. Okay. For example, I have a maintenance window, and maybe I need to shut down my infrastructure. Instead of shutting it down, you can move the virtual machines to run in the cloud, for example. Okay. Or you have an overloaded host, just like we've seen here in this example, and you need more. You have more requirement from the business that you need to provide the service. Hey, you can go and get the extra compute you need from the cloud. Cloud bursting, this is essentially the other use case. Provision your data center based on the average. And if you know that 1 month a year you have a spike, you need the stronger machines, for example. So pay 1 month in a year for this additional compute, and put your servers or your applications into the cloud. Any questions so far? Okay. Storage consolidation. This is the use case where we see our customers that have a distributed organizations across the world. Today, IT tends to consolidate as much infrastructure into the data centers, right? But the problem is sometimes users from around the world need to access the applications in a data center this way. So the performance for some of the use cases may be inadequate. And what we see that some of the customers, instead of consolidating now, are required to move back infrastructure to remote locations, some local servers. So why not leverage the hybrid cloud solution in this case? Our solution, what would look like is essentially you use your storage on the consolidated infrastructure in the data center, maybe for example here in Germany, and you have users across the world. Spin up a virtual machine and a close instance to those users in maybe in APAC or in US or I don't know anywhere else. The server instance will run close to the users, and it will access to the storage through the optimized channel that Velostrata provides. As we mentioned, we have a customer that uses it on a 180 millisecond connection between the compute and the storage. Hybrid disaster recovery, this is the use case where instead of, when you do a disaster recovery, for example, in the secondary site, you would normally have the storage, obviously, as well as compute replicated in case of disaster recovery, correct? So if there is a disaster recovery, you will have, you know, the compute and the storage on the secondary side. So with Velostrata, essentially what you could do is you can reduce the amount of infrastructure from the compute perspective in your secondary site, while putting or running the virtual machines in a cloud in case of disaster recovery. So in this case, I actually have maybe a slide in there. Yeah, I do. So if this is the standard situation, right? This is your primary, this is your secondary. You replicate the storage, and you also replicate the infrastructure for the, you know, for the compute. Disaster recovery or hybrid disaster recovery with Velostrata could be in your secondary site. You do still replicate the storage. Okay, the storage is replicated, but you don't need all the compute for your workloads. You will run them through Velostrata in a cloud. Essentially, what we need an ESX in the secondary site, from which, you know, into which you will install Velostrata engine, Velostrata virtual appliance, and then when disaster recovery occurs, you will run and you will essentially pay for the resources when actually disaster recovery takes place. You don't need to overcommit and, you know, and have these resources available. Okay. And the last use case is essentially a Deftest. What I wanted to show, it's not really seen well, but it's essentially, remember, with Velostrata, you can essentially extend, you can boot your images in the cloud in minutes without the need to change anything. And you can also use this, we call it a write isolation option, which means that the changes will not propagate. So, for example, if you need to reproduce some problem with your customer's environment, you create this, you have this lab. You right-click and you can duplicate this lab into the cloud. So you can have the Deftest. You can have the Deftest. If you leverage cloud for Deftest, you don't need to change anything, and you don't need to migrate the storage into the cloud as well. So I will now show you a customer case study if you're interested, an example, or you have some questions, maybe, guys, anything? We'll talk about the cost. You asked about the cost and the prices, so we can talk about. This is an example of a customer who they produce glass. They have an ERP system that 3 terabyte database that's based on Oracle. And they have 4 servers that consist, that build this application. By the way, the applications that you can move are not limited to database. It could be, of course, database, SQL, ERP type of, but it's not only for database. Essentially, it could be for any server that you want to run in the cloud. So this is the example of the customer with a CRM, with a ERP, application. So it has 4 virtual machines essentially that were built around this application. It took 20 minutes for the first time boot to transfer these machines into, this case it was into the Amazon public cloud. 20 minutes, after 20 minutes, your ERP system now runs in the cloud while the storage resides in your data center. Okay, and then they started running essentially the test scenarios, and it's hard to read here, but the important part is here that first of all, from the high level perspective, the outcome was that the performance is comparable to what they used to have when the application was running on premise. And essentially they noticed that the data store usage on-prem was offloaded. This is the clear benefits of the cache. You know, the multi-tier cache, fast cache is in the cloud. So some of the requests are addressed locally. So you can see here, these are kind of what is called readmes. The workload is being built. Once the workload is built, you now can, the performance is improving. So in that case, essentially, we were able to reach over 95% application cache hit scenario, because in this case with SQL, they have application level caching, and they also have an hour Velostrata cache hit. So overall, we're talking about average read IOs kind of was less than 10 milliseconds. So any application that is not too sensitive for an IO is a great candidate for to be serviced with Velostrata. So if we are there any kind of technical questions that you yes please?
Is it possible to see how vCenter is connected to Azure? You must provide credentials and so on. Is there a page or configuration page we could see?
So first of all, Azure support comes in early 2016.
Okay.
It comes next quarter.
Okay.
There is a certain setup that is needed to be done, and I'm more than happy to leave my contact. We could have a session with our tech technician guy. He can show you actually those things on the live system.
Okay.
Okay. Any other questions? We'll talk about in a second about the kind of the pricing and sizing. The customer continues or pays for the cloud compute to the cloud provider, not to Velostrata. Velostrata charges, we're kind of subscription-based product, and we charge per VM per year. So and it goes in bulks. So 50 VMs, for example. So you are able to move concurrently up to 50 VMs into the cloud. List price is for 1 year for 50 machines is about $40,000. Okay, and we can show the total cost of ownership and the return on investment compared to to what you're paying right now with a great ROI. So we actually see about 50% lower cost per VM when it runs with a hybrid cloud approach through Velostrata compared to the traditional performance. So just to summarize, if you really want to realize this hybrid cloud vision of being able to leverage public cloud compute on demand, you have to separate. You have to be able to detach the storage from the compute. Otherwise, there are so many barriers that are not possible to that prevent from customers really adopting this vision. So as I mentioned, the founders and the core engineering team essentially they have years of experience in building products acquired by Cisco, by VMware, and by Microsoft. Then one optimization, storage optimization, OS type of streaming solutions. So this is it essentially. This is what we do, and I'm more than happy. We have I think 5 minutes more if you have any questions, any more questions to address. I will leave my cards here, so if you want to also, for sure, you will be more than happy to proceed the conversation afterwards. Any questions? 1, 2, 3, gone. Okay. Thank you very much. This is not mine.
Ja, dann machen wir kurze Pause, klopfen bei.